So, good morning, everyone. We were discussing the specific heat, the two types of heat given to a body. One is specific heat, and one is known as latent heat. Okay. Now, we were discussing our specific heat, and whenever we give heat to a body, two things can happen. Either the temperature can change, or the state of the body can change. Okay. Now, I've given you these important values for water and ice. You can note them down. Moving further ahead, there are certain important points that you can remember about this, and this is as simple as it gets. I hope you know about isothermal process. You know about isothermal process, a process that takes place at constant temperature. Yes or no?
Sir,
So when the temperature is constant, the pressure the process is taking place at a constant temperature. This temperature does not change, and in that case, you can call the molar specific heat or specific heat as infinite or very large, because temperature is not at all changing. Even though we are giving heat to the body, the temperature of the body does not change. So we can call in that case the molar specific heat as infinite. Do we understand this? Yes or no?
yes, sir.
Yeah, in the other case where, I mean, since you all know this, I normally don't take this at this point, but since all of you know an adiabatic process, what is an adiabatic process?
D-
What is an adiabatic process? Everyone knows this, right?
DQ is equal to 0, sir.
Right. There is no heat exchange taking place between the system and the surrounding. In that case, we can say, we can call the molar specific heat as zero, because there is no heat given or exchanged between the body and its surroundings. We all understand this. So these are the 2 points that you should remember about specific heat, because these 2 points are going to come in the next chapter. These 2 points are going to come in the next chapter, which we'll be using very extensively. Last year JEE, I discussed 2 or 3 points, and the same question came in JEE Advanced. So please be very careful about what I am telling you right now, because this is a very important topic which has a lot of chances of coming in the exam. Okay. Now, whenever we talk about specific heat, let us first concentrate on specific heat. There are certain terms that come. One of those terms is known as thermal capacity. Thermal capacity.
Sir, can you preview the previous slide, sir?
Okay. Note it down. Once you are done, please let me know. Have you noted it down, bacha?
Yes, sir.
Okay. Let me then just take you to the next term. This term comes thermal capacity. I will define or denote this term by S. So I keep S for this term. Now, what is this thermal capacity? In simple language, if I just say M into C is equal to your S. So this is the amount of heat required to raise the temperature of any substance by 1 degree Celsius in CGS unit, or 1 Kelvin in SI unit. So if I multiply the gram specific heat with the mass, or 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 let me also add it here, or I multiply the molar specific heat with capital C. In both cases, I land up with my thermal capacity. Sometimes people also call it heat capacity. So remember this term, thermal capacity or heat capacity, is defined in this way. If you want to have a definition, this is the definition. If you want to note, you can note it. Definition doesn't matter. What matters is that you understand at this point in time how you are going to use it in exam. This is thermal capacity. One more term that comes is known as water equivalent. Water equivalent. This is denoted by W, water equivalent. I have again seen this term. Previously, it used to come a lot. These days, for the past 10 years, it has not been coming. But what is thermal equivalent? Let us again not get into the complication because the definition may complicate things numerically. Now, this this water equivalent is normally given in, remember, the SI unit of this water equivalent is kg. CGS unit is gram, because it is water equivalent. It is equivalent to water. The SI unit is kg or gram. If I talk about this thermal capacity, the SI unit of this is joule per Kelvin. The CGS unit is calorie per gram. Now, unit wise, they are totally different. Water equivalent is basically we are equating something with water. Whatever heat is required to raise the temperature of this body, how much will be the, if the same heat is given in this body, how much will the temperature of a particular mass of water will rise? It'll again look complicated, but if I talk about numerical value, the numerical value of water equivalent is equal to S, and I will try to make this in terms of an example that will be more relevant to understand this. So just write this here and I'll give you an example that will make you understand how to use this. So I'll give you 2 minutes to note this down and then I'll give you examples. Example is the best way to understand this. Okay, note this down. Once you are done, please let me know.
Done, sir.
Everyone has done this?
Yes, sir.
Let me now put a question and I will put the question in 3 different ways and let us see how it turns up in all the 3 different cases. So this is a simple example. A body of mass, and I will make this question in CGS unit. A body of mass 10 grams has C, I hope you understand meaning of small c, has C as 2 cal per gram per degree Celsius. Find delta Q. I hope you understand the meaning of delta Q. I'm writing it in short. To raise the temperature by 5 degrees Celsius. It's a very simple question. I'm just trying to make you understand the meaning of the 3 terms and it is best understood in this way. So this is the first way in which
100, sir.
I could ask you the question. So what is the answer for this one?
100, sir.
Delta Q will be equal to M C into delta theta. You just put the values 10 multiplied by 2 multiplied by 5 and you will end up with 100 cals. Let me put this question in a different way. So let us call this variation as variation A. Let me put the variation B. A body of wrong color. Why I'm using wrong color? I hate wrong colors. Okay, a body with thermal capacity or heat capacity. A body with thermal capacity 20 calorie per degree Celsius. A body has a thermal capacity 20 calories per degree Celsius. Find the amount of heat required to raise the temperature by 5 degrees Celsius. This is the next way in which I can write the same question. So in this case, how do you find out the heat given? In this case, how do you find out the heat given? Remember the relation here. If you want, I can write one more equation here. Delta Q in this case will be equal to S into delta theta. If that makes you more happy, you can write in this way also. Yes. What is the answer for this one? Yes, bacha. I hope you can hear me, you can see me. Yes or no? Anyone with an answer? No one? In this case, how will I find out delta Q? Delta Q will be equal to specific heat multiplied by delta theta. In place of giving you its mass and gram specific heat, I am straight away giving you its thermal capacity or heat capacity. So it is mass multiplied by the specific heat. So I end up with the answer 20 multiplied by 5, and I end up with 100 calories. Do we understand this? Yes or no? Raise hands will give me more confidence that since I can't hear you. Anyone understands it? You got this?
Yes,
Yes,
sir.
sir.
Okay. Let me ask the same question in a different way. Why do I use this? A body with water equivalent 20 grams. Find delta Q to raise the temperature by 5 degrees Celsius. In this case, my dear friends, I hope you understand the meaning of the three different ways.
100, sir.
Yes. This water equivalent 20 grams is actually, you can consider this body not as a body, but water whose mass is 20 grams. And for water, the specific heat capacity is 1. 20 multiplied by 1 is 20. So this basically becomes equal to this. Do we understand this?
Yes, sir.
That is how you can find out. And this is the best way that I have understood to understand water equivalent, because if I tell you the definition, it might just be so confusing. So you just multiply W by delta theta and you will end up with 20 multiplied by 5. You will end up with 100 calories. So this is how you understand this. I hope this is clear to everyone, because any of these three terms, water equivalent, I have not seen in quite a while in the exam, but you never know. They can put a question here. Are we ready for the question? Next one. Yes or no?
Yes, sir.
This is the next question. It has come both in JEE as well as NEET. Have a look and tell me how you are going to do this. Two spheres made of the same substance have diameters in the ratio 1:2. What is the ratio of their thermal capacities? Oops. Thermal capacity. 2 minutes.
Share. Share option B, share. Share.
Yes, my dear friends, any answer? You need more time?
C, sir.
Answer C, sir. So I've got
B, sir.
two answers, B and C. And the one who wins is B. But this is not a democratic win. This is a win by physics, by science. How are we supposed to do this? Just tell me who got the answer B. Tell me, bacha. How are you supposed to do this? Huh? Tell me. Gone.
Sir, it's a ratio of volume, sir.
Is the ratio of volume, sir. How do you get the ratio of volume? Remember, this thermal capacity S is M multiplied by C. Mass multiplied by specific heat. Now, remember, this specific heat, and this is the point that I want to make. This specific heat is a property of the material of the body. Specific heat, C, is the property of material of the body. They are made up of same substance, so the material is same. Material is same, that means C is going to be same. C is going to be same. So C is same. If I call the specific heat of first body divided by specific of second body, it will be in the ratio of their masses, M1 by M2. Now, this masses is volume multiplied by density. Same substance, same substance, same substance, same density. This is also same. This is also same. I hope I am making some sense here. So divided by V2 into rho, same substance. So basically it's in the ratio of their volumes. 4 by 3 pi r1 cube, 4 by 3 pi r2 cube, r1, 4 by 3 pi cancel. So it will be r1 by r2 cube. Diameters are in the ratio 1:2, 1:2. So radius are also in the ratio 1:2. So the answer is 1:8. Do we understand this? Yes or no? No, yes. Huh?
Yes, sir.
Got it? Okay. So remember these things. These are the questions that are more likely to appear in your exam than anything else. Because this term thermal capacity basically confuses most of the candidates. They start thinking thermal capacity in terms of their specific heat. Sometimes, especially in NEET, They might use the term heat capacity or specific heat capacity also they might say. That does not mean the specific heat. That means the thermal capacity. That's the term that they should use. Here comes the next one in the line. When 300 joules of heat is added to 25 gram of a sample of a material, its temperature rises from 25 to 45. What is the thermal capacity of the sample and what is the specific heat of the material of the sample? Remember, specific heat only depends on the material. So what is the thermal capacity of the sample and what is the specific heat of the material of the sample? The time starts now. 2 minutes you have.
A, sir, option A.
Option A is what I am getting. Democracy? What about others? Everyone getting option A? Democracy may win by science, not by voting.
Sir, going with the
Yes, bacha?
A.
A. So democratically answer is A, and this answer is based on science, so it is correct. There is no voting here because if you have to find out specific thermal capacity, it is simply delta Q divided by delta theta, and what I have is 300 divided by change in temperature. I think is 20. So I'll get the first answer as quickly as possible. As soon as I get this answer, I don't need to go any further because now I look at the options and the only option that matches is option A. I don't have to go any further. If there were other options matching the first one, then I could have calculated. That would not have taken a lot of time. Then I could have calculated C. C is S divided by M. Remember, M is in grams. So we have to convert it into SI unit. If you convert it into SI unit, you will end up with this answer, 600 joule per kg degree Celsius. Do we understand this? Yes or no? No, yes. Can I have reason from everyone in the
Yes,
class?
sir, understood.
Okay, well done. Then comes this one, and this is a question taken from one of your previous JEEs. When I say JEE, it was IIT-JEE, and therefore you will find some mathematical calculation that might trouble you, but I can't help it. It's a question from previous year papers, so I don't want to change the terms. I will just put the question as it is. More important is that you get the answer. You know how to do it. The specific heat of a substance varies with temperature as this. See, I don't know why they have given so many decimals and points. They could have made it simpler. But God knows. Something, something, something. The heat required to raise the temperature of 2 grams of the substance from 15 to no from 5 to 15 would be how much? The options are given. The only thing that it requires is patience. Take a deep breath. Look at the question. This question has come in one of the JEEs. It has to be a simple one. Solve it. Get the answer. Stay happy. This question is not likely to come in JEE Main. It's also not likely, definitely not likely to come in NEET. Yes, bacha. Anything that looks like an answer?
No, sir.
Okay, I guess it requires some some amount of time. I can understand this. It's purely calculation. The only thing they are checking is a calculation and not much else afterwards. I'll give you enough time to solve it. Shall I solve it for you, bacha?
Sir, wait for 1 minute.
I shall wait for 1 minute. I told you, I could have changed the values of this question. Since this has come in one of the JEEs, I just don't want to change the values. Okay. I guess you remember how to integrate stuff. So how do I solve it? Just see.
Sir, option C, sir.
Option C, sir. Wow. Good. I said wow. Just because you calculated correctly. Because this question was all about calculation. Well done. How are we supposed to do this? So I now have to use delta Q is integral of M C D theta. I just put the values, get the answer, and I stay happy. So this is integral from 5 to 15. I hope you understand. To put the limits, it will be 0.2 plus 0.14t plus, I don't know why so many zeros, 0.023 t square, or should I write t square into, let us write dt because they've written in terms of t, dt. We just integrate this and we put the limit. So integral of 0.2 will be 0.2 t. I will put the limit. I understand that it will take time for you to calculate this. I can't help it. This is a question from one of the JEEs, t square by 2. Put the limits. They only need to check. They were only checking whether you know to integrate and put the values. Plus 0.023 divided by 3 t cube. Again, a bit of calculation, and I'm very bad at that. So I leave it up to you. And the answer that I have is 82 cal. So I think you must end up somewhere here on 82. Do we understand this, everyone? This type of question is more not likely to come. If this question comes, all these things would be given very generously, that you can calculate it easily, because the time that you have is very less and you can't spend so much of time in calculation. Do we understand this? Can we move ahead in life?
Sir.
Okay, the next type of heat that we are going to encounter. So first we will introduce this gentleman more. We have up till now we have introduced three definitions. One is specific heat, the other one is thermal capacity or heat capacity, the third one is water equivalent. Comes the fourth gentleman of this chapter, which is known as latent heat. The literal meaning of latent is hidden. Latent heat means hidden heat. Now, what is this latent heat or hidden heat? This heat is required. This heat does not change the temperature of the body. This heat is required to change the state of the body. This heat is required to change the state of the, why I'm writing state of the body. And this heat only comes at two specific temperatures. What are those temperatures? This heat only comes at melting point, and this heat only comes at boiling point, and therefore you will have two types of latent heat. One will be known as latent heat of fusion or melting, which is used to change liquid into solid or solid into liquid. The other one will be latent heat of vaporization, which will be coming at boiling point of that body, and it will be used to convert liquid into vapor or gas into liquid. That time it is known as latent heat of condensation. Do we understand this? Yes or no? So
Yes, sir.
this is what you need to understand if you have to write the important points. Here are the important points. We can note them down. I will tell you the important points. We will note them down. Again, it is more of your understanding. If you understand them, you don't have to. I will just highlight those important points that include the definition. Now is not the time to write the definition. I hope you already know it. So it's basically used to change the state from solid to liquid or liquid to gas. This heat is known as latent heat, hidden heat, because normally what we understand by heat is you give heat, temperature changes. Here temperature does not change. No change in temperature is involved, only change in state. It is also known as phase transformation heat. Remember, it's an isothermal change. So if someone tells you the example of an isothermal change, this is the example of an isothermal change. Ice melts into water, water evaporates into steam, whatever, not evaporates, boils. The amount of heat required to raise the state, change the state of m mass of a substance is m into L, where this L, so that is the important point that you have to write. M into L, latent heat, is denoted by the legendary letter L. I've not seen L used anywhere apart from length. Latent heat, L, and the SI unit becomes joule per kg. The CGS unit becomes calories per gram. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everybody will have two types of latent heat. I will again give you. Do you want to note this down? What things I have noted down? You can just note them down at points. You don't have time to write the entire thing. Not you, not me. Just note down the important points. Number one, use for change of state. Two types of latent heat. M into L is the formula. no change in temperature. That is how you must note it down. Do we understand this? We will have two types of latent heat. Don't have to note everything down. You can just write. One heat is known as what? Huh? First heat is known as? Have you noted this down? Shall we move ahead in life? Huh?
Wait, sir.
Noted down the important points.
Yes, sir.
Then we have two types of latent heat. Latent heat of fusion. The reverse of this is melting. Fusion is the process in which liquid becomes solid. Melting is the process solid becomes liquid. The process is same. In one process, heat is given. The other process, heat is taken out. For ice or water, latent heat of fusion is 80 calories per gram. That is what you need to remember.
Sir,
Yes, beta.
once your previous slide.
Okay. Do it fast, beta. Do it fast. I think you know this, right? I think all of you know this. Yes or no? Just note down the important point. Point number one, I've written it already here. It changes the state. Point number two, there are two types of specific heat. It does not change the temperature, no change in temperature. So you can write delta theta is equal to 0. That's it, no change in temperature. Isothermal process. And then you need to note down this formula. That's it. Nothing else. Do it. Not a problem. Do it.
Done, sir.
Let us wait for everyone. In writing notes, it's a democratic country. So unless all of you write it, I can't go ahead. Getting the answer is not democratic because it's based on science. Writing is democratic. It's based on the combined opinion of all. Shall we move ahead, bacha? Shall we move ahead? I think I've lost the voice, so I think that this time is enough to do this. Now the next thing is latent heat of melting and latent heat of fusion. Heat required to change the state from liquid to solid or solid to liquid. For water, it is 80 calories per gram. Latent heat of vaporization to change the state of 1 kg or 1 gram from liquid to gas or gas to liquid. For water, this value is 540 calories per gram. Do we understand this? I'll give you 1 minute to note this down and I'll move forward. Life has to move forward. We need to move forward in life. Are we done?
Sir.
Okay. We then move forward in life. Now, This is the point on which we had a question in the previous year JEE, and I will give you the gist of it. So if this question comes, you should be able to solve this. Now again, we can't do this question at this point in time because it requires something else. So I'll just go through this when we are boiling or melting something. As I told you, heat supplied is used to increase the internal energy of the body and also in doing work against external pressure. Remember this. I think you know this this equation, delta Q is equal to delta U plus delta W. Do we know this equation, everyone? Yes or no? Do we know this equation, everyone? There's a point here that tells us this is the reason why the internal energy of steam at 100 degrees Celsius is more than that of water at 100 degrees Celsius. I've seen this question come in a variety of exams, especially in NEETs. What will cause you more burn? Water at 100 degrees Celsius or steam at 100 degrees Celsius? The answer is definitely steam at 100 degrees Celsius because it has a lot more energy, lot more internal energy compared to water at 100 degrees Celsius. So that question is meant for NEET. This one, this equation, do we remember this equation? Anyone? Does anyone remember this equation?
Yes, sir.
Yes, sir.
Now, I think let me just check whether I have that question. Let me just check. Give me a couple of minutes. We'll just go and check the question whether I have that question. If I have that question, well, probably we can solve it now itself. Here. Let me see if that question is there. Let me see if that question is there. Oops, not this one, not this one. It came in this year's JEE. So if I see it here, let me just see. Not this one. Ah. I got it. I'll show you a snapshot of it. And the good thing is, I mean, it was a match the following, so I can't show the exact entire question because that will just create a lot of fuss on my this thing. I'm just showing you a snapshot of that question that came, and actually I covered it in the crash course that I took this year only. I'm just showing you a snapshot of this question. This question is from JEE of this year, the JEE that's happened, and the question was like this. This list describes it was a big list, and if I have to show you the entire list, the entire question that came in JEE was this one, and you can understand. So I'll show you the entire question as well, and then we'll come back to this this particular one. So it is quite small that you can, I hope not see. This was the entire question number 17, I think paper number 1. This question came, and the question was like this. There were 4 different questions. There are 4 different options, 4 different questions in one question, and obviously the entire question we are going to cover in this class and the next class, and then we had a couple of options. You had to tell which is the correct one or not. We cannot do part number 2, 3, and 4 right now, but what we can do is part number 1, and this was exactly the same question, not the same value probably, maybe the value was also same that we discussed in the class, and I think students were able to do this obviously. List A describes thermodynamic process in 4 different systems. List 2 gives the magnitude or a very close approximation of possible changes in internal energy. So on the right hand side you have some values of internal energy, changes in internal energy. On the left hand side you have some questions in which you have to find the change in internal energy. So this is question number 1 from list 1. 10 raised to the power minus 3 kg of water at 100 degrees Celsius is converted into steam at the same temperature at a pressure of 10 raised to the power 5 pascals. The volume of the system changes from this to this in the process. Latent heat of water is also given 2250 kilojoule per kg. You have to find out the change in internal energy. We did the same question in the class last year. So whatever point I am telling you, they are all questions. One of those points will come as a question. Can you do this one? Huh? Can you or can you not? You have 2 minutes to show your talent, because in JEE Advanced you had to do 4 questions in 2 minutes. And they were very simple. You could have done it in under a minute. Because if you look at the options, you just had to solve any one question of the 4. So it was 4 in 1. The simplest one you solve, and probably you will end up with the answer. Anyways. Yes, my dear friends. Oops. Are you trying? Have you got the question, bacha? Huh?
Yes, sir.
So try. The world is all yours. The universe is yours. 4% of which we see. That 4% is beautiful. 2 minutes you have to score. I think +4 in a JEE. When I say JEE, I don't count JEE Main as JEE. Well, why I'm giving you this question at this point in time? Normally, to do this question, you should know this equation. I guess you know this equation, the equation that I have written. Then you need to know how do you find out this thing. You should know how you find out this thing, and I guess you know this. Normally, when I do this question with 11th standard students, I do not normally do it now. I would probably do it after some time. Yes. Anyone with an answer? I'll tell you the options that are given. One option you can see is 4 kilojoules. The second option, I think, from the list is 7 kilojoules. The third option is 4 kilojoules. The fourth option from the right hand side is 5 kilojoules. And the fifth one is 3 kilojoules. And remember, when it comes in a JEE, it can be 1 to many and many to 1. But what I mean by 1 to many and many to 1? What I mean by 1 to many and many to 1 is that a question can match, a left-hand side can match more than one option on the right-hand side. The right-hand side can match more than one option on the left-hand side, vice versa. Yes. Shall I do it? Huh? Not able to solve it? Shall I do it?
Yes, sir.
Yes, beta. Are you solving it or shall I do it?
Also,
Okay.
please solve.
What was so difficult in this? Remember, difficulty is only in our heads. You can solve that part out. Everything is simple. The only thing that you had to know in this question was delta Q. How do you find out delta Q in this process? Tell me. I just now told you. How do you find out delta Q? Yes. Tell me. Help me in solving it.
Sir, do it, sir.
How do you find out delta Q? I will do it, but tell me how to find out delta Q. Amount of heat
Sir,
required.
sir.
How do you find out amount of heat required?
ML.
Yes, ml. M is given, L is given. M, I think, is given as 10 raised to the power minus.
Minus 3.
How much is L? 2250. Okay. You have to find out delta U. Okay, delta U is question mark. How do you find out work done? This process happens at a constant pressure, but something has changed. What has changed, my dear friend? What has changed?
P into V2 minus V1.
That's it. And that is your answer, my dear friends. You have your answer. And that is exactly correct. P into V2 minus V1. Just have to do that. How much is the pressure, my dear friends? 10 raised to the power 2, I think. Kilopascals, whatever. Multiplied by V2, 10 raised to the power minus 3 minus V1, 10 raised to the power minus 6. So you got delta W. You got this. You got this. And you know the equation. You can calculate.
P is equal to 10 to the power of 5, sir.
Yes, you can now calculate delta U from here, my dear friends. So delta U becomes, oops, I'm writing Q. Delta U becomes delta Q minus delta W. And here is the answer. The answer that I have is 2.15 kilojoules. So the most approximate value from the table is 2. So the answer is 2 kilojoules. Do we understand this? See, we understand this.
Yes, sir.
Was it so difficult? No. Since this question came in a JEE, it has to be simple. And that is the first thing that you must understand about any question that ever comes. It is a simple one. And see, that is what you need to understand. If you look at the entire question, and this is the entire question that is there with all the options, let me show you the options as well, just to make a point here. See, all the options were different. This is how you do smart hard work. Look at all the options. This question was only a 4 marks in a JEE, and this had 4 questions. So that means 1 mark for every question? No, not that way. Now look at the option here. And that is how you work smartly. Look at the option here. If you just solve question number 1, the entire question is solved. You don't have to solve 2, 3, and 4. Are you getting my point, bacha? Because option first has all the options which are different. So if you get the correct answer for first one, you can mark that option as correct. So we got 2 as the answer for the first part, first question, and 2 happens at P. 2 happens at P. P is given as 2. That means the correct answer is. That is why I said this year JEE Advanced was pretty damn simple. The answer is D. You are done. +4. And how much time did you take to get that +4? Less than a minute. Am I making sense or am I talking nonsense? This is how you do smart work. And this is how, if match the following comes, you act smartly and you just don't see the question, start solving everything. It was a lucky thing that the first option had all the different ones. So if you would have solved first, you would have got the answer. But it may happen that may not be the first one. The second one may have all the different options. The third one may have all the different options. If now no one has all the different options, then what do? You solve the first one or second one, which you think is the simplest, which you think is the simplest. And all of these are simple. All of these are less than 15-20 seconds. You think which is the simplest of all these four, solve that one and see which option is matching. Then there might be two options which are having the same thing. For example, if I look at this one and if I look at this one, the two yellow ones, if you think that the option question number 4, which is this one, was the simplest among all, and it is simplest, all of them are simple, then you solve option number, then you solve question number 4, you get the option as Q, then you look for the second simplest one, because with Q you have two options. Then you look for the second simplest one, solve that second simplest one. If you could have then solved for option 3 are different in both the cases. In one it is S, in second one it is T. You don't have to solve all the 4. Are you getting my point, bacha? Look for the simplest one. So these type of questions are coming. The first one may not be the correct, the first one, to solve the first one may not be the right choice. Here it was lucky because all of these were having different options. Do we understand this, or this has gone above our head saying bye bye, I'm going? Huh?
Understand, sir.
Got this? Did you get the moral of the story? Don't panic. You look at such a big question, don't panic. You just have to solve one question to get the answer. Okay? Shall we move ahead in life? Life has to move on.
Yes, sir.
Life cannot remain stagnant. And this is the next one that we are going to do. And this is more likely to come in the present day scenario. It has come many times, multiple times in NEET as well as in your JEE Main. And here comes the question, and this is the question that tells us how to understand conversion from one point to the other point. Work done. Oops. In converting 1 gram of steam, 1 gram of ice at minus 10 degrees Celsius into steam. Do not take it as work done. Just take it as delta Q right now. So they have not talked about change in volume and change in everything. So we just take it as delta Q. Find the amount of heat required to convert 1 gram of ice at minus 10 degrees Celsius into steam at 100 degrees Celsius. Nothing is given to you, so you must remember the specific heat of water. Why I'm writing it as S? I should write it as C. The specific heat of water is 1 calorie per gram per degree Celsius. Specific heat of ice is 0.5 calorie per gram per degree Celsius. Latent heat of water is 80 cals per gram. Latent heat of vaporization, LV, is 540 calories per gram. Do you know all these values? Even if you don't know, I have given you the values. The values are there. The question is there. Best of luck. Yes, my dear friends.
Option A, sir.
Option A, 3045. That is absolutely correct. Well done. What about others? Do we understand this? How it is done? I'll give you 1 more minute to solve it with your own hands. So, and I'll tell you how I do it. And obviously, you can have your own ways of doing it, but I'll tell you my way of doing it. So, if I had to do it, what do I have at the beginning? I have ice at minus 10 degrees Celsius. So, what would I do first is convert this. Oops. What would I first do is convert this to ice at 0 degrees Celsius. I will have to give it some heat. How much heat I have to give it? That will be delta Q. Remember, heat is given, so it is always positive. Delta Q will be M. How much is the mass? 1 into specific heat is 0.5 multiplied by temperature is 10. I hope you understand this. So this will be 5 calories. Yes or no? So this is step number 1. I have converted ice from minus 10 to 0. Now I come to ice at 0 degrees Celsius. What do I do to do next? Is to convert it to water at 0 degrees Celsius. So now I'm changing the state. This is happening at the melting point of water. The heat required will be equal to delta Q, mass into L, M into L. Mass is 1. Latent heat of melting or vapor or fusion is 80. So here we get 80 cal. So far, so good. Can I have raised hand from everyone that you understand this? Huh?
Yes, sir.
Okay. Then I move on to the third step. And in the third step, what I'm going to do is I'm going to convert this water at 0 degrees Celsius to water at 100 degrees Celsius. Now I am raising the temperature of water. So what do I need is that I need the specific heat. Remember, here, I was using specific heat of ice because I was raising the temperature of ice. Here I will use the specific heat of water because now I'm dealing with the change in temperature of water. Mass is 1, specific heat is 1, and change in temperature is 100. So this one is actually the latent specific heat of water. I hope everyone understands it. That will get me 100 cals more. So now I have water at 100 degrees Celsius. Now what do? I move on to the final step. And the final step is to convert water at 100 degrees Celsius to steam at 100 degrees Celsius. For that, I require change of state. Change of state delta Q is equal to M into L. In the first case, I had used the specific heat, latent heat of vaporization. In the second stage, I am going to use mass is 1 into 540. This is the latent heat of vaporization that I have used. I end up with 540. I add all this. I will get answer in calories. To convert the answer from calories into joules multiplied by 4.2.
4.2.
Yes. So how much is the answer in the calories that you are getting, bacha?
25. 725.
725.
Yes, sir.
725 is the answer in cals. I just convert it into joules. So I multiply this 725 by 4.2 and I end up with the answer in joules. And I think multiplying by 4.2, I will end up somewhere around 3045. And that is the answer that we had to do. Everyone understands this? This is how I do it step by step. You can use your own methods of doing it. No problems. I have no problems. Absolutely. Everyone got this? Yes or no? No, yes. Okay.
Sure.
Yes, bacha. Any doubt, bacha?
Sure.
Please, beta. I'm listening. Any doubts? Shall I move ahead in life?
Yes, sir.
Okay. Then I have moved ahead in life, and this is a simple question that has come in one of the JEEs, and it can come again in your NEET as well as in your JEE. If mass energy equivalence is taken into account, and water is cooled to form ice, mass of water should 10, 10, 10, 10.
Option B, sir.
Option? Option B, sir. Yes or no?
D.
D. First increase, then decrease. What makes you feel so? Now remember, whenever we are changing the state of the body, what happens is the internal energy of the body changes.
B, sir.
B, sir. Okay, sir. So remember, mass will always remain constant no matter how you take it. Please remember this question. If it comes, just mark, just mark, just mark the remain unchanged option. Move ahead and stay happy. And that was the question that I was talking about. No, the next question was the question that I was talking about. It has come many times in many exams. So just give me the answer so that I can move ahead. Compared to a burn due to 100 degrees Celsius of water, what is the burn due to steam? Ting, 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 ting. You have 4 options.
Sir, option A.
Option A, more dangerous. Why it is more dangerous? Because when water converts into steam, 540 calories per gram has to be given, and that has
Sir,
got. Yes, beta.
energy is more for steam, sir.
Energy is more for steam because of the latent heat of vaporization. We all understand this. Remember, the same question will come in your NEET, maybe in your JEE as well. And again, this is a type of question I've seen in many times in many exams. This is taken from one of the previous paper of JEE Main. So this is the question. I can't change any value here. This is the question coming next. I hope I can get an answer quickly. Question number 4, I forgot a number. Latent heat of ice is 80 calories per gram. Wow. A man melts 40 grams of ice by chewing in 1 minute. He's an ice chewing man. His power is, power. Power, 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 power. Okay, enough of songs. You have 1 minute to solve this.
Option B.
We have an answer, and that is option B. And that is the correct option. Remember, these are the type of questions that are going to come in your JEE Main. You just have to be patient. Take a long breath. Understand that this question has come in JEE. It has to be simple. And then go about solving it. How did you do it? You have to find the power. So first of all, you have to find how much heat is required to be release because ice has to be converted into water. So you have to give heat to the body. How much heat you have to give? M into L. M is 60 grams. 60 multiplied by 80. That is the amount of heat that you need to
4,800.
4,800. But that is in calories, my dear friend. So we have to multiply it by 4.2. Multiply it by 4.2. That is the amount of heat. We need power. So I don't calculate it there. I will just first write the entire formula. Power is this divided by time. Time is 60 1 minute, 60 seconds. So I will put 60 here, then I will divide. So you see what happens is this becomes simpler to calculate. Yes or no?
Yes, sir.
So that is the answer. 80 multiplied by 4.2. You don't have to multiply 80 by 4.2. You look at the option and you tick. That is what you call doing smart work. Do we understand this? You don't have to actually multiply 80 by 4.2. So I'm also telling you the short tricks. People call it tricks. It's not tricks. This is smartness. Don't have to calculate it. The options are so different from each other that even without any eye, you can pick the right one. Yes or no? No, yes.
Yes, sir.
Don't have to calculate it. Look at the option, mark it. So this is all about mass and specific heat, and to give you any further question won't be possible because we'll have to do something before doing it. So we'll move on to the next heading of this chapter, and the next heading of this chapter is known as principle. Everyone has noted this down?
Done, sir.
Method of mixture.
Method of mixture. Okay, you can call it method of mixture, but I call it by its original name, principle of calorimetry. Principle of calorimetry. And what is this principle of calorimetry? I will not go much into theory of it. We all know this, right? We all know this, yes or no? Whenever heat transfer is taking place, one body is gaining heat, the other body is losing it or rejecting it. Whatever I am gaining is being rejected by some other body. So heat lost is equal to heat gained. Do we understand this?
Yes, sir.
This is known as the principle of calorimetry. I think just writing this is good enough. Writing this is good enough, but if you want to write it in more detail, I will tell you the exact definition. If you want, you can write it. That will not make much sense because if you understand the definition, we just have to use it to our benefit, and this is it. When two bodies, there can be any two bodies, that can be body and surrounding. For example, a hot cup of tea kept in atmosphere. Hot cup of tea is hot, atmosphere is cool. So this hot cup of tea will lose heat, atmosphere will gain heat. One body is losing heat, the other body is gaining heat. The body which is at a higher temperature will lose heat. Everyone knows this. The body which is at a lower temperature will gain heat. Heat loss is equal to heat gain, is based on the law of conservation of heat energy. And this is a question that can come as what is the principle of calorimetry based on for NEET or JEE Main? That is the point that you need to highlight and write. Delta QG is equal to delta QL. Heat gain is heat loss. We know this. That's right. This is based on the law of conservation of heat energy. Do we understand this? Yes or no? No or yes? Some people also call it law of mixture. Doesn't matter. It's the one and the same thing. Principle of calorimetry, law of mixture, doesn't matter. Have you written this down? Yes or no? No, yes.
Yes, sir.
Now the same thing I'm going to give you as important points. More often or not, you may come across cases where we are going to mix two bodies with each other. When I talk about mixing two bodies, obviously you cannot mix two solids. You are going to mix two liquids with each other, and that is what is known as this law of mixture. So one body will be at a higher temperature T1, the other body will be at a lower temperature T2, and once you mix it, they will come to a temperature T. Yes or no? Now remember, this T that the mixture of the temperature of the mixture, it will always lie between the hotter body and the colder body. Do we understand this? Yes or no? When you are mixing two bodies,
Yes, sir.
the temperature of the mixture is always greater than the lower body temperature, but it is always greater than the lower but less than the higher body temperature. I hope I have not made a mistake. So this is the point that you must remember. This is only about mixing two liquids together or two gases together, probably not mixing one solid inside other. This is one solid, I put another solid inside that solid. It's only meant to be done for two liquid bodies. Do we understand this? Yes or no? No, yes.
Yes, sir.
Don't have to write the entire history of this thing. Just write what I've highlighted, and that is more than enough for you to solve any question that comes on this. Yes or no? No, yes. Okay. Then you can also note down again. Remember JEE main or when I say JEE main is JEE main JEE main or NEET just test of your speed. So more often or not, you might encounter a case where you will have two bodies mixed with each other. When I say two bodies, they are two liquids. They are mixed with each other. One will have temperature T1, mass M1, specific heat C1, M2, C2, T2, mixing together. Whee, what is the temperature? So this is the answer. Don't have to do everything, heat loss, heat gain. Whatever you do, you will end up with this. Yes or no? No, yes.
Yes, sir.
Well done, sir. Note it down, sir. You don't have to do all those heat gain, heat loss. Just put this formula, get the answer, and stay happy always. Staying happy is important. That is the prime thing that you must always remember. This is the general formula. I hope you understand this. Now you can make some special cases, and this is more relevant for NEET students and for JEE Main. You can have some special cases where you have bodies of the same material, where you have bodies of the same mass, where you have bodies of the same material and the same mass. So if you want, you can write these formulas as well. But remember, all these three formulas are derived from the first formula, which is highlighted. I hope you understand this. In first formula, if I put C1 is equal to C2, I will get formula number A. In the first formula, if I put M1 is equal to M2, I will get formula number 2. In the first formula, if I put M1 and M1 equal to M2, C1 equal to C2, I will get formula number 3. Do we understand this? Yes or no? No, yes. So this is gone about what I'm saying. Bye bye. I'm going.
Yes, sir.
Yes, sir.
You got this now, sir?
Yes, sir.
Okay, sir. Then I will give you a minute to do it. Let's see if you can wind this up, and the questions are waiting for you after this. So note fatafat so that I can move ahead in life. You know, we have to always move ahead in life. Life cannot remain stagnant at a point, but then it becomes clumsy. Have you done this? Yes or no? No, yes.
No, sir.
So we will have a question that has come in many times in JEE, not the exact question, but with different values, and as well as in NEET. Can I move ahead? Democracy. What does democracy
Yes,
say?
sir. Yes, sir.
Democracy says yes, and I am obliged to democracy, and this is the question. And I need an answer fast. A liquid of mass m, specific heat C, is heated to a temperature 2T. Another liquid of mass m by 2, specific heat 2C, is heated to temperature T. These liquids are mixed. Whee! What is the resulting temperature? You have 1 minute to do it.
Sure, option D.
I have an answer which seems to be
Option D.
option D, democracy. Here we have got a democratic answer, but this democratic answer is based on scientific facts. And that answer is definitely answer D, 3/2T. So how do I get it? I don't have to write heat loss, heat gain, and this and that. I can straight away remember JEE or NEET main. The speed of your test, test of your speed. So I can simply write this T as M1. M1 is M into C into 2T plus M2 is M by 2 into 2C into T divided by M1 C1. So M into C plus M by 2 into 2C. I hope you can do the multiplication and division and you will end up with 3/2. What you have to understand is 3/2 is basically in between 2T and T. Do we understand this? Yes or no? No, yes.
Yes, sir.
I hope all of you have done this.
Yes, sir.
Comes the
Yes, sir.
comes the next one, my dear friends, and let us see who gives me the answer to this one first. Look at the question. Take a deep breath. This has come in one of the JEs. And straight away, tell me the answer. What will be the answer for this one, my dear friends?
B, sir.
And the answer is B, sir. What not? Because that is the only one option which is dimensionally correct as well. So the option is B. Do we understand this? Yes or no? No, yes. Huh?
Yes, sir.
Everyone understands this? Now remember, whatever formulae that we have done is only made for liquids mixed together. So you can do it, you can straight away put the formula and get answer and stay happy. But sometimes you might have one or more than one body losing heat, one or more than one body gaining heat. And they might be at different temperatures. So just do not apply this formula everywhere. Be a little cautious and apply it in the condition that is given. So I'll give you the next question. This one should hold good. This question came in one of the Olympiads of my time. A beaker contains 200 grams of water. The heat capacity of the beaker is 20 grams of water. I told you in my days, things were asked differently. This is a question from the Olympiads. I hope you understand what are Olympiads. The initial temperature of water in the beaker is 20 degrees Celsius. Ooh. If 440 grams of hot water at 92 degrees Celsius is poured into it, what will be the temperature of the system nearest to? Specific heat of water is not given. You must know that it is 1. Rest of everything is given to you. Best of luck. Let's see who gives me the answer. I'm waiting patiently for it.
Sir, option C, sir.
Option C, sir. Democracy. You got a democratic answer? Well, democracy never always wins. Democracy only wins when it is backed by facts, backed by fines, backed by false.
Option B, sir.
Option B, sir. So another democracy says option B. This is backed by science and this is backed by facts. So that is the correct option. Option C. No, option B. How you got to do this? Remember, the only thing that we have learned in this chapter is the principle of calorimetry, my dear friends, and the principle of calorimetry says that heat gain, heat lost is equal to heat gain. Who is gaining heat? Who is losing heat? We just have to find out those gentlemen who are gaining heat and who are losing it. Let us say the final temperature is theta. Let us say the final temperature is theta. So now who is gaining heat? Who is losing heat? The hotter body will gain, will lose heat. So heat loss, gentlemen, is this. So let us find out how much heat it will lose. How much it will lose? Mass is 440 multiplied by specific heat, that is 1, multiplied by the change in temperature, that is
92 minus.
theta. Do we understand this? Yes or no?
Yes, sir.
Let us find out the gentlemen who are going to lose heat here, or who are you to gain. Give me. So this beaker has water. So 20 grams of water is at 20 degrees Celsius. So this is the first gentleman that is going to gain heat. How much heat is going to gain? 200, the mass, into 1, plus the change in temperature for, why have written plus? 200
minus 20, sir.
multiplied by theta minus 20. This is the first gentleman which is going to gain heat. But there is also this beaker. Now this beaker has a heat capacity
Plus 20 into theta minus 20.
Yes, which is equal to 20 grams of water. So now what you can do is you can cut the process short. So the beaker has 200 grams of water and this beaker is equal to 20 grams. So instead of writing it as two different things, you can write it as one different thing. The total amount of water, which also consists of beaker, because beaker is taken as water in terms of heat capacity. I can write this as not 200, but I can write this as 220. Do we understand this, bacha? This 200 is for water and this 20 is for the beaker. Do we understand this? Huh?
Yes, sir.
So this must be equal to this. After this, it is very simple to calculate the temperature theta. It is as simple as you get it, and the value of theta that I have with me is 68. So that is the answer. So this is how you use the water equivalent. This 20 grams of water which was given for the beaker was the water equivalent of the beaker. I hope you understand this. Yes or no?
Yes, sir.
Well done. If you have understood this, that was the entire reason of giving you this question. And the next question, which has come, I think, just in this year, JEE Main, I saw this question. in one of the sessions of the JEE Main. Not sure about the values, but similar question that has come many times. So because this is an industrial process and you are going to get into the industry, so this is a question that will hold you in good stead. In industrial process, 10 kg of water per hour, that is how they made the question interesting. 10 kgs of water per hour is to be heated from 20 to 80 degrees Celsius. So you are probably working in a boiler industry and you want to heat water quickly. To do this, steam at 150 degrees Celsius is passed from a boiler into a copper coil immersed in water. The steam condenses in the coil and is returned to the boiler at a temperature of 90 degrees Celsius. How many kg of steam is required per hour? That is the question, my dear friends. The time starts now. Yes, my dear friends, do we have anything that looks like an answer? Huh? Tell me first. Or shall I do the needful?
For one.
No, you don't have any options here, so you have to tell me the exact answer. Yes, bacha. Oh, you have. Sorry. I did not see the. Oops. Sorry. I'm sorry. I did not see the entire question, and I did not give you this information. So please forgive me for this. Specific heat of steam is given as 1 calorie per gram. That was not given. I did not see it. I just now saw it. And latent heat of vaporization is 540 calories per gram. I think that was, I'm sorry. Yes, beta.
Sir, option
Option B. C.
Option.
I only see option. Don't get after what option.
Kg, sir.
10 kgs.
1 kg.
1 kg is correct. And oops, wrong color. I hate wrong colors. Again, wrong color. Something has happened here, which is not good. So I need to probably take this away because something happened which is not good. Now I'll put it again. And I hope better reading prevails now. Okay, now this is good. Oops, it is still not good. What has happened? Okay, just give me a minute. I need to probably do what I don't like. I just have to come back to it because I think it got stuck somewhere. Just give me a minute. Got stuck. Things get stuck. We need to find ways to make things moving, and I think now it is moving. So basically 1 kg is the answer. What I need to do is I need to identify who is gaining heat and who is losing heat. And I hope you have identified the losers and gainers. Delta Qg is equal to delta Ql. Who is going to lose heat? The green gentleman. The green gentleman is steam. Steam is at 150 degrees Celsius. It condenses in the coil and returns to the boiler at 90 degrees Celsius. Good. So this is a gentleman who is losing heat. How much heat he is losing? Tell me fast. Huh?
10,000 into 1 into 60.
Okay, so the amount of heat it is losing will be m into L because it is condensing. At the same time, it is okay. There are three things that is happening here. Let me put it that way. That would be better. There are three things it is happening there. First, this steam at 150 degrees Celsius is going to come to 100 degrees Celsius. So in that case, how much heat is lost? 10,000 grams multiplied by 1 multiplied by 50. That is the first stage. Steam getting from 150 degrees Celsius to 100 degrees Celsius. Then it converts into water at 100 degrees Celsius. So then it is 10,000 mass multiplied by latent heat, 540. I hope everyone is following me here. This is for steam from 150 to 100. Then water has to convert from 100 to 90 degrees Celsius. So again 10,000 grams of water multiplied by 1 multiplied by 10. Do we understand this? This is for water. Do we understand this? Then I look at the gentleman who is gaining heat. Oops. I've done it wrongly. I've taken 10 kg as the mass of the steam. It was mass of water. So my apologies. I will have to take the mass of the steam as m. So mass of the steam is m into 1 into 50 plus m into 540 plus m into 1 into 10. Now who is gaining heat? The gentleman that is gaining heat is 10 kg of water from 20 degrees Celsius to 80 degrees Celsius. So how much heat it will gain? I will write it here, 10,000 multiplied by 1 multiplied by the change in temperature, that is 80. This must be equal to whatever terms are on the right hand side. We equate this and from there you get the value of m. Do we understand this? Yes or no?
Sir.
So that is 10 raised to the power 3 grams, which is actually equal to 1 kg. Do we understand this? I taken 10 kg as the mass of steam. I was wrong. The mass of the steam was what we are supposed to find out. Okay. So do we understand this?
Yes, sir.
Now, before going any further, I would show you one thing which has come in exams a lot number of times, which is known as your heating curve. Have you seen this heating curve? Do you know what is this heating curve? And then we will solve some beautiful questions there. Have you seen what is this heating curve? Anyone? No? Okay, so I'll show it to you. I will save some time in not drawing it and probably use that time in explaining.
Sir.
Yes, beta. Yes, beta.
One show previous question, sir.
One show previous question. Anything wrong with that? Yes, here's the previous question.
80 or 60?
No, 80 or 60. Yes, it is 60. Change in temperature is from 20 to 80, so it should be 60. That is correct. Sorry. 10,000 into 1 into 60. That is correct.
Okay, sir.
Thank you. Shall we move ahead?
Yes, sir.
Heating curve. Now, I've seen a lot of questions come on this heating curve. So just have a look at this. What is happening is we probably have a solid body. We can take the example of ice. We have ice at some temperature. The temperature is not negative here, so you might not take it as ice, but you might very well take it as ice. So you have a solid body at some temperature. You give heat to it. So what happens? Its temperature starts to rise. And you are giving this heat at a constant rate. You are giving this heat at a constant rate. So first of all, the temperature of this solid body will rise. It will keep on rising till it reaches its melting point. Now at this point, if I give it heat, the temperature will not rise, but the state will change. So the temperature will remain constant, but the state will change. It will convert from solid to liquid. If I keep on heating it, the temperature of the liquid will increase. It will keep on increasing until it reaches its boiling point. At the boiling point, the temperature will remain constant. If you still give it heat, the temperature will remain constant and the body will change from liquid to gas. When it converts from full liquid to full gas, again temperature will keep on rising. This is represented in this curve. There are 2 points that you have to see here. One is the melting point and one is the boiling point. Do we understand this? In first case that I see, which is this one, I am giving heat to a body and the temperature is rising. This is heating of liquid. Do we understand this? This is heating of solid. Do we understand this? Yes?
Yes, sir.
The angle of inclination here is alpha. Now, this angle tells us how fast or how quickly that body is heating up. If it is heating very quickly, this curve will be very steep because the specific heat for solid is always the least. Do we understand this?
Yes, sir.
Now, when it reaches this point A, which is the melting point, if I give it heat, it will not change its temperature, but it will change its state. It will start to melt from solid to liquid. The heat given in this process is M into L. Do we understand this? It will keep on melting unless the entire solid converts into entire liquid. So at point B, at point A, we have total solid. At point B, we have total liquid. Do we understand this?
Yes, sir.
In between point A and B, we have a mixture. We have a mixture of some solid and some liquid. If I keep on heating it beyond point B at the same rate, what will happen? We come to this stage where we are doing the heating of the liquid. Now this angle beta, as you can see, is less than alpha. That is less steep. Why it is less steep? Because specific heat of liquid is always greater than the specific heat of solid. Therefore, it will take more time for the liquid to heat compared to the solid body. Do we understand this? This fact is note it down at the last of this table. Alpha is more than beta. That is more than gamma, because thermal capacity or heat capacity or specific heat of gases is more than the specific heat of liquids, is more than the specific heat of solids. Do we understand this? Yes or no? We understand this? Yes or no?
Yes, sir.
It will go till a point C. Till the point C. The point C is the point where it starts to boil or evaporate. Not evaporate. Evaporation is a different process. Boil. So at point C, we have total liquid. At point D, we have total gas. And between C to D, temperature cannot change, temperature remains constant, isothermal process, change of state is taking place, and here we are using the latent heat of vaporization. What thing you have to understand is this region is greater than this region. Do you see this? Why it is that? Why is that so? The blue region is smaller than the whatever color is that region. Why? The blue region is smaller, but that yellowish color is bigger. What color is that? Not yellow, it's orange. Something somewhere between yellow and orange. Yes. Why is that more? Huh? Why is number 2 region more than number 1 region? Tell me. That is the point that you have to note, because the question will come on this point only. Yes. Why is region number 2 more than region number 1? The length I'm talking about. Why does it take more time to boil the same liquid than to melt the same solid? Yes, my dear friends. No answers? Well, number 1 is smaller than number 2. Number 1 is smaller than number 2 because latent heat of melting is smaller than latent heat of vaporization. So it will require more heat to boil it, to change the state from liquid to gas, as compared to changing the state from solid to liquid. Remember, latent heat of melting of water is 80 calories per gram, whereas the latent heat of vaporization of water is almost 4 or 5 or 6 times, 540 calories per gram. Do we understand this? I think I've lost contact. Anyways, I'll give you 2 minutes to note this down. If you have any problems, any doubt, please ask. Once you're done, please let me know by whatever means that you can.
Done, sir. Done, sir.
Everyone done, sir? Democracy
Sir.
should win here. This is the democratic process. Shall we move ahead in life? Life has to move on.
Sir.
Huh? Yes, sir. So I'll take the democratic answer. And the next thing that comes is, my dear friends, a question from your previous year JEE, and I will just wait for the answer to come as quickly as possible, my dear friends. As quickly as possible, the answer should come. And the answer is, I will not even read the question. I hope you are good enough to read the question, give me the answer, and stay happy always.
Sir, can you show previous page?
Okay,
Option A, sir.
so we are still stuck in the previous page. Okay, so have a good look at this, because this question has come many a times, and that is what I was showing to you. Anyways, I'll give you time to note it down. The purpose of this class is that whatever we do, we do it to up till a level where we are confident of cracking it. If we do it and we don't understand what we have done, the purpose of this class goes away forever. Don't want you to do that. I don't want that to happen. So, have we understood this? Region number 1, region number 2, I've told you everything that you needed to know about this. Any question that comes on this heating curve, you should be able to do it. Done, 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 done. Shall we move ahead?
Yes, sir.
Arey, you to already done this. Democracy wins. Okay, so we are done with this. We move on to this question, which is definitely a question that has come in your previous year JEE, and this is the question 2002 marks. JEE Advanced, that was. This question has come in
Option A,
JEE
sir.
Advanced. Yes, my dear friend, and I already have an answer, and the answer is option A. Do we understand option A?
Yes, sir.
Ice. Ice is heated slowly. So first of all, look at this small line, and it is a very small line. Oops. The temperature will rise, then it will reach its melting point, then it will melt, then the liquid will rise, then it will reach its boiling point. Do we understand this?
Yes, sir.
So the correct option is
Yes, sir.
option A. C. Shall we move on in life?
Yes, sir.
In life, we also always need to move ahead, and this is the next question which will move ahead after 4 years. Liquid oxygen at 50 Kelvin is heated to 300 Kelvin at constant pressure at 1 atmosphere. The rate of heating is constant. Which of the following graph represents the variation of temperature with time? Yes, my dear friends. Liquid oxygen. Liquid oxygen has come.
Sir, option C.
Option C, democracy. What about others? Is it a democratic answer? Huh?
C, sir.
B, C, and C. You see, is the correct answer C. No questions asked. No explanations given. Liquid oxygen. If you heat it, first the temperature will rise. It will reach its boiling point. It will convert into gas. Constant temperature. That latent heat of vaporization, and then everything goes away. Shall we move on ahead in life? Huh?
Wait, sir.
This is the actual question from which all of these questions were derived. It came in the JEE of the year 1985. That was the first time this question ever came in a JEE.
Sir,
And
one show previous question, sir.
see, so you should not always be in a haste, because sometimes you might be the first one to answer. Sometimes you might not be the first one. So we always wait for democracy to win. Shall we move ahead?
Wait for 1 minute, sir.
Okay, I shall wait. Democracy always wins. Shall we move ahead in life? Life has to move on. Can't remain stagnant. Huh? Yes or no? Are?
Done, sir.
Yes, sir.
Then done, sir. This is the original question from which everything was derived. So this is the question. JEE of the year 1985. 2 marks. Whether it's 2 marks, that is the previous JEEs. By JEE, I mean JEE Advanced. Or it may be IIT-JEE. The variation of temperature of a metal as heat is given to it at a constant, it is given in the figure. The material in its solid state at point O. What is the state of the material at point P? At point P, my dear friends.
Ice plus water.
Ice? Huh? It was not ice. It was not given ice. You can't assume that it was ice and there was water. Then
Half solid, half liquid.
yes, partly solid, partly liquid, not half. Okay, if it is exactly at the middle, and again, it is mathematical expression. So you can't say half solid, half water. You will always say partly solid, partly liquid. Do we understand this? Yes or no? Partly solid, partly liquid. Do we understand this?
Yes, sir.
Sir.
Yes or no? No, yes.
Yes, sir.
Yes, sir.
Okay, sir. So we are almost done with this particular chapter, and then I only have 15 minutes left. I can't do much in 15 minutes. So what I'll do is I will present questions, very fresh questions from very fresh days, so that you understand that you have done almost everything that was required to be done, and we are now ready to tackle some questions. And here comes the first question, my dear friends. 2019 JEE Main, 12th April, first session. The question is right in front of your eyes. Your target is there. Let's see. Who does this? And remember, there is a pattern that I have seen in JEE Main session. And please remember that pattern. I am going to tell you that, and I'm going to prove it to you. What happens is, it's a general pattern. If in first session, a question comes from a particular topic, please mark my words. In first session, if a question comes from a particular topic, in first session, if a question comes from a particular topic, in all the sessions, the question will come from that particular topic. I hope you have noted it down. So if you're doing it, if you're giving session 1, you might not have an idea which topic the question is going to come. But in the next section, next session, from which topic the question is going to come. Do we understand this? Yes?
Yes, sir.
Write it in big stars, big stars. If a question comes from one topic in one session, in next session, question will come from the same topic. Well, this is the question. What is the answer? I'm giving you some background music as well to keep company. Are we getting anywhere near something that looks like an answer? Feels like an answer?
Yes, sir.
Sir, yes, sir. Are you asking me this, sir, or are you telling me this, sir?
Telling, sir.
Telling, sir. So you're giving me the answer, sir, not asking a question in return. Yes. A or B or C? The answer is A. Dun, dun, dun. So you got the correct
A,
one.
sir.
Congratulations, well done, A sir. So that would have given you a lot of confidence. See, the question was pretty damn simple. How are we supposed to do this? Anyone? How are we supposed to do this? So basically, what you got to do is apply the same concept of what? Delta QG is equal to delta QL. Now, who is going to gain heat? Who is going to lose heat? Obviously, we have ice and water. So water is ice is the gentleman who is going to gain heat. Tung, 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 tung. So we have ice at minus 10 degrees Celsius, and ice is going to melt, and whatever is left is water at 0 degrees Celsius. So ice, whatever heat is gaining, whatever heat ice is gaining, tell me that. Let me call the yes, beta.
M1 into 0.5 into 10 plus M1 into L.
0.5 we don't know. That is what we have to calculate. Do we understand this? 0.1 we don't know. 0.5 we don't know. It is not given. No, it is given. Latent it is. Latent heat we have to find out. I thought the specific it is not given. Okay, so latent heat is given. So I'll take that word. So M1 into 0.5 multiplied by 10. This is the heat required to raise the temperature from minus 10 to 0. Plus, we have to melt it. So M1 into latent heat we have to calculate. I thought that we need to calculate specific heat. Latent heat we need to calculate. M1 multiplied by L, that is the heat gain. Who is going to lose heat? Where is the gentleman? This gentleman is going to
M2 into 50.
M2 into 50. That is correct. So I'll just write it here. Oops, 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 oops. M2 into 50. The only unknown here is L, and you should get the value of L. And the value of L that you are getting is option number A. Yes or no? We understand this, everyone?
Yes, sir.
Remember, this is 2019 JEE Main April session 1. Can you move on to the next question?
Yes, sir.
Sir.
The most important thing that you're going to read in the next question is in which session, in which year it came. And remember, when one question comes from one topic in one session, the same process is repeated for different sections. So this again, from the same topic, same year, different session. 100 gram of liquid A at 100 degrees Celsius is added to 50 grams of liquid B at 75 degrees Celsius. The temperature of the mixture is 90. What will be the temperature of the mixture if 100 gram of liquid at 100 degrees Celsius is added to 50 gram of liquid at 50 degrees Celsius? Yes, bacha. The only thing that you need to do here is to calculate it quickly. If you can do that, the glory is all yours, my dear friends. Shall I help you out? Or you would be able to manage? Huh?
Give hints.
Give hints. Well, the only hint I have is the only thing that I've told you. And the only thing that I've told you is this. That is the hint. That is the only thing that we have done in this entire chapter. And that is the only thing that you got to do in this question as well. Trust me. There is nothing extravagant about this question. It's a simple question that should be solved like this. Shall I do it? Apply the equation in the first case. Who is gaining
Option
heat?
B.
Option
I'll
B
wait
is
for 1 minute.
democratically given answer. Option B is the correct answer, actually. I'll wait for 1 minute, don't worry. The only purpose of this class is to make you understand that we have done everything. The only thing is you just have to be patient. I'm not patient. See, I make mistakes, stupid mistakes, which you should not do. Read the question carefully, see all the data correctly, see what you got to do. You only know one thing in this entire chapter. Heat loss is heat gain. So everything in this chapter has to be done by the same thing. I wait for 1 minute, don't worry. Who is gaining heat? Who is losing heat? Let's see. Liquid B is gaining heat. Liquid A is losing heat. Equate it. Something you know, something you don't know. You will get a relation between that quantities. Then use that thing in the next one and you are done. Don't have to even, if you are smart enough, remember, physics can only give you a formula. To solve it, you need maths. At the end of the day, what matters is how good you are at maths. And when I talk about maths, I mean simple maths, simple things. How to solve equations quickly. How to see if we are getting this, how can I get a quicker answer? That is all that you need. Okay, shall I do it?
Option B.
Option B is correct, beta. Let me do it for everyone. Heat gained. Heat will be gained by liquid at B. Liquid B, 50 grams of liquid. I do not know a specific heat. No problems. I will write mass as 50 into specific heat of B multiplied by what is the change in temperature of this liquid. Final temperature is 90. Initial temperature is 75. So change in temperature is 15. Yes or no?
Yes,
That
sir.
is equal to heat lost. Let me look at the heat lost. Heat lost. Body A is losing heat. I still don't know. It's specific heat, not a problem. I know it's mass 100 multiplied by specific heat of A multiplied by change in temperature. Initial temperature is 100, final is 90, change in temperature is 10 degrees, 10. This is equation number 1. From this equation number 1, you can calculate CB in terms of CA. That is one way of doing it. Or you can use another way. Why want to calculate CB and CA? That is what we call smartness. I again use the same thing in the second case. This is case number 1. I again apply the same thing in second case. Heat gain is equal to heat lost in case number 2. Who is gaining heat? Who is losing heat? Heat gain. Obviously, this liquid is again going to gain heat, but here I do not know the final temperature. Doesn't matter. The mass is 50 grams. 50 multiplied by specific heat of B into the change in temperature. Let us call final temperature as theta. So it will be theta minus 50. That must be equal to heat lost. Who is going to lose heat? This gentleman. 100 grams of this gentleman. 100 multiplied by specific heat of A into temperature is going to be lower. So I write 100 minus theta. This is the equation in case number 2. Now, how do you solve this equation? You have a variety of ways in which you can solve this equation, 1500 different ways. What I would have done is I would have divided 1 by 2. So I just divide it by 2. So when I divide, what happens is these gentlemen simply go away. 50 and 50 simply goes away. 100 and 100 simply goes away. So what I have is a very simple equation. 15 divided by theta minus 50 is equal to 10 divided by 100 minus theta. From here, you can easily calculate the value of theta. Do we understand this? Yes or no?
Yes, sir.
Any question will require some amount of maths. This is the math that it requires. This is simple math. This is 8, 9, 10 standard maths. Division, multiplication, solving equations. If you can do this quickly, you can end up with a lot of questions in the correct time. And just to tell you the point that I was making, I'll give you a glimpse of all those questions that came in the same JEE. And I'm going to show you. So what I mean to say, see these two questions, same topic, same year, same session, not same session, different sessions. What I mean to tell you is, again, mark my words, whatever I am telling you, I don't have time that we can do all this. Again, same topic, same year, different sessions. If one question from one topic comes in one session, not the same question, from the same topic, you will get question in the next sessions. And I'm sure you can do them. I will end this class on this note. We are done with calorimetry. I had planned that I will start with your KTG, kinetic theory of gases, but it was not possible. The more important thing is whatever we do, we must be confident about it, and we should be able to solve question if it comes in a JEE Main, in a NEET, or in a JEE Advanced. I hope we have served that purpose. We wind off calorimetry here. In the next class, we'll start with KTG, kinetic theory of gases, and try to wind it up. It's a vast topic because it covers a lot of things. So we'll try to do as much as possible, but whatever we do, we must make sure that if a question comes from that part, we should be able to do it. I end this class here. Take care. Have a nice day. God bless you all. Bye-bye. Any doubt, you can always come up to